Good morning. Here we are again. And I want you to notice, if you look in the Google Classroom, how I have added in the lecture we've been working on. So far, we have reached all the way through to this point. And our next topic is sexual selection. And we'll have authoritative mating, we'll discuss what a species is, and talk about isolation and how species can evolve through isolation or by reproductive barriers. And then talk about rates of speciation, and I guess that's about it. We probably won't make it that far today, though. So let's start with the sexual selection slide. We'll turn the page, move on, because we're done with that one. And today we're going to talk about sexual selection. And it's pretty easy to think about this, is that in order to pass on your genes, one must be selected, an individual must be selected in order to have that happen. So sexual selection is the preference in an individual. There's an IV. Individual to select a partner with specific or positive traits. And the thing is, sexual selection is a very strong force for evolution. Simply because you can survive, you can be a good runner, a good regulator, you can be all of these different things in your environment, but if you're not selected for, you're not going to be able to pass on your genes to the next generation. And so we see with sexual selection, there are big changes that can happen in an organism. One of the things that we see, and that I want to point out because there's lots of obvious examples in nature, is something called sexual dimorphism. Sexual dimorphism is a condition where males and females of the same species have different traits. And this is something that is strongly sexually selected for. And of course, we can think about that huge tail on a peacock, and how if the tail of a peacock is interesting in that they've done studies and they seem so cruel, but they've taken a peacock and removed, they just went in and cut all of his tail feathers off. And sadly, if you do that, it doesn't matter. Like, you can take the most successful peacock in the flock and remove his tail feathers, and sure enough, there isn't a single female that will mate with him. He falls to the bottom. So there is a really big preference for the tail. And so naturally, if there's a preference for your tail, that looks nothing like a peacock, I'm sure, but that's fine. You'll forgive me. There's a preference for the tail. There are other, when you think about birds and how birds have really intricate dances, they can do a dance, they can have tail feathers. There's a lot going on that they need to be able to pull off in order to be able to mate. And so when we look and we see a difference between males and females, those traits are probably strongly selected for sexually. I have here on the slides different other traits that we might see. We often see, like with spiders, the females can be much, much larger than the males that can be tiny in stature because they're being selected for that way. One might think that it's because the females are carrying eggs, they must be larger for that purpose. Other examples are kind of creepy. There is a fish that lives down at the bottom of the ocean, and it's known as a angler fish, and it has a funky mouth. Oh, I'm drawing and you're not seeing it. That's wonderful. And this fish is a really large fish, and it has a little thing sticking off of the top of its head that prey might be attracted to. And as prey approaches this fish, they're going to get swallowed up by the large fish. And that is sort of how they make their living. You've probably seen or heard of them before. But maybe the thing you haven't heard is that these big creatures that we see are all female. And down on the abdomen or the bottom of the fish is its male partner. And the male partner is tiny. He's just a little guy, and he hangs out there on the belly of the fish. And in some cases, I think he can get enveloped in to the skin of the fish, so he becomes permanently sort of attached in there. It seems weird, but all he does is produces sperm and fertilizes the eggs of the anglerfish. It's like his only job in life. I don't know. He must like it, I guess. But there you go. Different types of body shapes come about because of this thing called sexual dimorphism and selection that's occurring between these different organisms. You look at the next slide, it says, I'll just put it here. This is the next slide. It's assortative mating. And lots of species do this assortative mating thing. So I'm going to squeeze it here on the bottom because I don't think we need a lot of space. And what this means is that a lot of species, most species, oops, that's an S, not a P. I was thinking about my next word, which is prefer to mate with an individual that is like them. And I'll say it like this. So what do we mean by that? Well, this slide here shows a study of some fruit flies. And these fruit flies were all sort of raised together in one batch. And then over time, the fruit flies were separated out into two. I wonder if I can make this bigger. No. Separated it out into two groups. one was fed a certain type of food, a maltase-based food, and the other one was fed a different food source. And interestingly enough, over several generations, these guys all ate sort of this one food source, and these other ones fed and ate only the other food source. And then they took all of the fruit flies and they put them back together into the same habitat, and they watched. And what they discovered is that the fruit flies, ooh, look at that. The fruit flies that ate the same food source were more likely to pair up, like by a lot. So these guys that were eating this yellow food, I suppose, is the way they've labeled it, they got together and had offspring, and the ones that were eating the brown food got together and had offspring, even though they had equal opportunities to mate with each other. We see this in all kinds of populations where, even with whales and such, where they have very specific family songs or songs that they sing underneath the water that are going to attract females and males to each other that are not necessarily closely related, but they are culturally the same in that they have the same sort of family ties. Anyway, kind of interesting that species, and that's individuals in a species, tend to prefer to mate with individuals that are like them. And maybe we see that in humans as well, maybe not. But when you go to find your husband or your wife, you're going to be probably looking for similarities, things that you both have in common. And so that assortative mating kind of falls into that same category. So we'll put a little heart there. I didn't color any of this page, and that goes back to my need for a pencil sharpener, but I'll get a handle on that. I'm going to pause it there for today, and tomorrow I think we can go on to talking about what specifically a species is, which is our next slide. So we've got 2 things, 1 page worth of work here, where we're talking about sexual selection is preferences for a mate based on traits that they have. I want you to watch a video I'm going to attach to this assignment, and it's on birds and mating, and I think you're going to like it. So spend some time, watch that. I think it's only a few minutes long. And then along the bottom, the assortative mating, I don't think I have any kind of video for that. So we'll just have to enjoy the one on the birds. So that's your assignment for today. Have a good day.